My name is Nancy Baker. I'm going to do a training video on how to use the abstract sifter for AOP, Adverse Outcome Pathway Development. I have just run a query, hypospadias. It brought back about 9,000 records. I think it's 9,070 records. It's a fairly large corpus, and they are all here on the main sheet. So my job now is to take this corpus, 9,000, and find out, get some ideas about what chemicals cause hypospadias and what are the gene protein players that I can use to build my pathway. So first thing I'm going to do, and this is what I always do when I'm looking at this sort of thing, and I've built my AOPs in the past, I'm going to go here and extract the mesh substances. I'm going to pick major topics and say, okay, what this is doing is going through each one of the rows here on the main sheet, taking the mesh terms for genes, proteins, or substances like drugs, chemicals, and extracting those and counting the occurrences of those terms. I found 882, the abstract sifter found 882, and here they are, and you can see by looking at this list, these are mesh terms from the mesh dictionary for different substances. Some of them are families of things, biomarkers, plasticizers, corticosteroids, glucocorticoids, and I usually delete the family terms first because they kind of feel like they're in the way. We have an article count, and I'm going to go ahead and sort largest to smallest, and I can see that the largest number of substances in these articles are things like testosterone. Makes total sense. I want to divide this corpus of substances into organic things that would be probably drugs or pesticides or environmental chemicals, and I'm going to show you how to work with those, and then I come back and show you how to work with genes and proteins. So I sorted on organic, or selected one basically. That means these are all organic chemicals, so these are, we can look at them and see chemicals. Some are pharmaceuticals and some environmental. The first thing you then can do too here is double click on a row, anywhere in a row, and see what articles are there. So here, what that does is write that term into the first sifter term and then sorts by it. So I hope you are all familiar with the abstract sifter and all the different functionalities it has. So here's, you can see then the richness here. So you have articles that have 5 times mentioned dibutyl phthalate and then hypospadias. So these are articles that are definitely about hypospadias. And we have rats here. These are very rich articles about dibutyl phthalate, hypospadias in rats. Hope you all know how to take notes. One of the most powerful things about the abstract sifter. So let's say these things are really important articles that I know I'm going to use in my AOP, my paper, whatever. I can just go ahead and maybe on the paper, AOP. Now they're green, so I don't have to re-tag them. I know I've looked at them already. Okay, so here's where you then read and evaluate. You can also, if you read it and find that it's interesting, you can add a note from here as well. And go look at the notes you've got and go back to main. But this is where you interact with your corpus. I'm going to go back to the mesh mind sheet again. And so the next step is I'm going to take this list of chemicals and I'm just going to take the top ones, and I'm going to take the ones that are all 5s. No, not enough. Just take those names and dig farther into them from a data point of view. There's another sheet here called curated lists that I use quite often to pull lists of chemicals. Oops, that's not what I wanted to do. Pull lists of chemicals together. What I'd like to do now is get their DTSX ID. This is the identifier that the EPA has given these chemicals. And once you have that, this is DDE, I believe. once you have the list of the DTSX IDs, you have available to you all sorts of information. You can get their synonyms, you can get mass, and I'll just show that briefly. Let's just pick something simple like average mass. Maybe not very relevant to this particular study, but okay. Once you have the chemicals, you can do a lot with them. And now I'm going to go back though to MeshMine and look at which genes and proteins are most associated with this are most associated with hypospadias because they occur the most in this corpus in the mesh terms. So you can see these are genes, proteins. If you don't know what they are, you just click on it. It's an easy one, estrogen receptor 1. But some of these, I don't know what this one is. Mastermind-like domain containing one. Okay, never heard of that, but okay, that's what we learned. So you can, again, then go read how are these things associated with hypospadias. This protein here, there it is in that title, Genetics of Hypospadias. Okay, I'm thinking that's going to be an important article. And I can start building up my notes corpus that will be the most helpful in building the adverse outcome pathway. So back to MeshMine. Now, another fun thing, something we did at the EPA is that literature says that these mesh substances are highly associated with hypospadias. Next question for us at the EPA was, are any of these genes or proteins tested in our ToxCast Tox 21 libraries? So if you click on more, it will go and colorize those things that are in ToxCast. Now, ToxCast didn't have everything, of course, so I'm only going to look at, I don't want to neglect these ones that aren't in ToxCast, but I want to look and see if some of the chemicals that I've already pulled out are associated with these things in ToxCast. So I'm then going to select them again and send them to the bioassay sheet. So what that did, it took those proteins and found all the ToxCast assays associated with them. You can tell this is estrogen. Can I make you go away? Here are the different genes. There's STAT3. All these different assays are in ToxCast. And now I can take my list of chemicals here and see which one of those are actually in ToxCast. They're not all going to be. Need that one then. And I should go read about it, but I won't have any ToxCast information. Okay, so now I'm going to take this information, copy it, and go to bioassay and put that there. Okay, so I'm going to check then for these chemicals, is there ToxCast information that they, testing results that show they interact with these genes and proteins that literature says are important in hypospadias. And I'm clicking on this, okay, clicked on EPA Custom, I forgot to show you that. So EPA Custom has all these special custom menus. I'm going to get bioactivity for these rows. And I'm going to go ahead and pause this so you don't have to wait. All right, so all of these results in ToxCast have been retrieved and returned on this sheet. Let's look at this sheet. We have the chemicals here, the assay names along here. We have counts. We also have an indication what the genes are that are being tested for. And a query, this is a query that can be run I'll show you that in a second. It can be run and bring back results to the main sheet. The problem there is that you don't want to delete what's on the main sheet because there's your query about hypospadias is there. Okay, so this is a lot of assays, and it's kind of hard to read all this. So one thing I'm going to do here is dibutyl phthalate. I'm going to pretend like that's the chemical I'm most interested in, and I'm going to sort columns by that selected chemical. So these are all the assays that dibutyl phthalate is positive in, has a 1 in, and I've sorted by that. So we don't even have to look for dibutyl phthalate anymore. It had 0 results in many, and then it wasn't even tested. That's what the hashes are in many others. I can also then say, okay, if I have a large corpus, here I can pretty much visually look at it. But if I have a large corpus, I might want to calculate the similarity and then sort by that. Okay, so this I'm going to pause it here. I'm not sure why that's a 1. Okay, well, I don't know how to explain this right now, but that's not a good thing to do. I mean, it's not very meaningful. So we can also sort by hit count total, and that sorts by how many hits here per which of the assays has the most hits in this particular corpus. So this can give you some idea whether the chemical that you might be interested in as a stressor also has some data in ToxCast that either can support or not support your idea about that stressor. If you want to, too, is you can also double-click on a cell, and that builds a query and will send the results to the main sheet. Problem there is it will delete what's on the main. Well, you can append it, but I'm not going to do that now. So that's a good way to build out evidence for your adverse outcome stressor. All right, now I'm going to go back to MeshMine and look again at these genes and proteins in my pathway. Of course, the most important thing to do is go read about how they are linked to hypospadias and take notes and just think about what your data is. The other thing that you can do, and I'll just take a couple of these here, I'm going to copy those and go to landscape sheet and paste it on the landscape sheet there, and make this look a bit nicer. Okay, I'm pasting them in the query part here, and here too. What I'm going to do is build a landscape sheet here so I can see the relationship between these genes and each other. So when I do this and colorize it, what I've got here is the number of articles in PubMed that satisfy this query. So we've got estrogen receptor alpha and collagen. So I'm looking at the relationship. So this is a sort of thing you can do to build out your pathway. Find out the relationships between your genes and proteins. Maybe that's not the best aromatase, TGF beta, and you can then also, because TGF beta is TGFs, so you might get more results if you add a clause in there that says TGF, and you can append it, or you can delete it and add, but that deletes your main sheet. So here visually you can see the relationships between your genes and proteins, and maybe get some insight that'll help you build out your pathway. When I have built adverse outcome pathways, these are techniques that I have used, and when I find something of interest, I always put it on my note sheet so I can go back and make comments. This might be AO, this might be step 1, and maybe, I think these things are going to help me with step 1. And these two are going to help me with step 2, and I'm just making these up here. And so here's where you could organize your thoughts about the adverse outcome pathway. So those are some tips. If you have any questions, send me an email, nancycolebaker@gmail.com, and thank you for joining.